Welcome everyone to another video which is again related to the force vectors. This is problem number 16 from chapter 2nd in the book of Engineering Mechanics, the Statics part by R.C. Hibbeler. This problem is very similar to the one which we have solved in our previous video, which is problem number 15. In previous video, we were given with this theta angle and we were asked to determine the resultant of these two forces. But in this case, problem number 16, we are asked about the direction of FB force, I mean theta, and we are also being asked to determine the magnitude of the resultant force. What we are being given? We are given with the magnitude and direction of FA force, the magnitude of FB force, and the direction of the resultant force, which is along the positive x-axis. So let's solve this problem. So these forces are actually acting on this plate. So let's consider the plate on which these forces are acting. One force is FA, which makes an angle of 30 degrees with the positive y-axis. The other makes an angle of theta with the positive x-axis in anti-clockwise direction, and that has a magnitude of 500 pounds. Now in this problem, we are not going to use the cosine law first to determine the magnitude of the resultant force. That's because we don't know the angle of theta. If we don't know the angle of theta, then we cannot determine the angle between these two forces. Therefore, we are directly going to use the sine law. And to use the sine law, first we have to form a triangle, and for that again we have to move one force by taking the tail of that force to the head of that first force. So let's displace FA force and place at the head of the FB force, like the one you can see here. And as it is given to us that the resultant is along the positive x-axis, and that will actually be the closing side of this triangle. So then this will be actually the resultant force. Now if you look at this triangle, you can see that we don't know this angle, we don't know this angle as well, because we don't know theta, so we cannot determine this angle. But somehow we can have this angle, because if this angle is 30 with the positive y-axis, so this opposite angle will also be 30. So if this is 30, then this will be 60 in order to make it 90 from x to y. So only we know it is this interior angle. So we can have one term of the sine law, that is sine 60 divided by the magnitude of the opposite side, which is 500 pounds FB force. Now that will be equal to what? If we are going to use FR, then we don't know this angle, and if we are going to use FA, then again we don't know this interior angle, but we can determine this theta angle by using the sine theta divided by the opposite side, which is 400. So from here we can have the angle of theta. On doing calculations, we are going to get 43.9 degrees as the theta angle. Now if we know this theta, then now we can determine this interior angle. How we are going to do this? So if we have a imaginary line here, so if this angle is theta, so this angle also be theta. So if we have this vertical line where if this is theta, then this will be 90 minus theta, and this angle is 30. So now sine of this interior angle, which would be 90 minus theta, which is 43.9, plus 30, which is going to be divided with the opposite side, which is the resultant force. And now we can use either this term or this term. Both is possible now. I'm using sine 60 over 500. So in this equation only FR is unknown, and on doing calculations we are going to get the value of FR as 561 pounds. So we were asked about the magnitude of the resultant force, we just have calculated, and also we were asked to determine the angle theta which this FB force is making with the positive y-axis in clockwise direction. That also we have determined. So I think that's all from this solution. It was quite straightforward. There was some bit of geometry here. So I believe I made it easy for you guys to understand. But if still you feel that you cannot get what do I mean by solution, then just let me know through the comment section. I will try my level best to come back to you. That's all from this video. I hope to see you in next coming videos. Till then, bye.